As we said in example number 2, notice that the limit as x approaches to 3 is 6, even though f of 3 is not equal to 6. In fact, f of 3 does not even exist, because the expression x squared minus 9 over x minus 3 is not defined at x equal to 3. It means this point, an important point about the limit. Yani, look at the function. Sometimes we don't have value of the function at the point of x, 1 point of x, or maybe more than 1 point. Look at this shape or this diagram. Y equal f of x. What is the limit of f of x when x approaches to c? The height is L. So from the left and from the right, I can see that the function is going to the same point. So the limit is L. Now, what is, here fc is undefined because I have a hole here. It means the function does not exist at this point. Now, the second graph. When I have this one, what is the limit of g of x when x goes to c? Also, I have limit here because the function, when I approaches to c from the left and approaches to c from the right, going to the same point. It is L. And gc, the function here, the value of the function is not equal to L. It is equal to n. It is different of the limit. So gc is equal to n. The third situation, the point here, the limit of h of x when x approaches to c from the left is L, from the right is L also. What is the value of h of c? It is also L. So here in this point, in this situation, the limit equivalent to the function value. In this case, we speak about that later. In this case, the function will be continuous. In this case, I have limit, I have limit, I have limit. But only in this case, the function is continuous. Because if I put my hand or my pencil on the paper to graph this function, I can graph all the line without releasing my pencil on the paper. Here I will remove my pen to put a point here and continue again. Here I will remove my pencil or pen from the graph, from the left graph part to redraw the right part. So the definition of the limit is, I will study if the function have limit from the left, if the function have a limit from the right. After that, if the limit from the left equivalent to the limit of the right, then I can say that the function has a limit at x when x approaches to c, which is equal to L. Example number 3. Estimate each one-side or two-side limit if it is or if it exists. A. What is the limit of 2x inside absolute value over x when x approaches to 0? This sign negative, it means when x approaches to 0 from the left. Now he is asking me also to find the limit of 2x over inside absolute value over x when x approaches to 0 from the right. Now, is the limit from the left equivalent to the limit of the function at the right? If they are equivalent to each other, it means I have a limit at this point. When x approaches to 0, look, he didn't write anything here, positive or negative. It means he is speaking about the limit. Is it exists or not? Look at the graph. The graph of f of x equal 2x inside absolute value over x suggests that 2x goes the function 2x in absolute value over x, what is the limit of this function when x approaches to 0 from the left? It is equal to, when x less than 0, the value of 2x will be what? Positive, but x will be negative. So we can remove x with x and we have negative 2 over negative equal negative 2. When we will speak about the right hand side of, or when x approaches to positive 0 from the right, we can replace 2x, it is positive also already, and x is also positive, so positive over positive give us positive. 2 over 1 equal 2. Look at the limit from the left and the limit from the right. Are they equivalent? No. So the limit of the function 2x inside absolute value over x when x approaches to 0 does not exist. Look, if I draw the line, I will stop here, remove the pen, and start again from another point. B. What is the limit of g of x when x approaches to negative 3 from the left? Look at the arrow from the left. I'm going to negative 3 from the left, sorry. Here I will go to the point negative 3 from the right. Are they equivalent or not? I will study that now. What is the definition of the function? It is piecewise function for if x not equal to negative 3 and negative 2 if x is equal to negative 3. The graph of g of x suggests that the limit of g of x when x approaches to negative 3 from the left, it means it is equal to 4, because from the left or from the right I have the same value. It is equal to 4, and the limit of g of x when x approaches to negative 3 from the right equal also 4, because the value of f of x equal to 4 when x is not equal to negative 3. So here I have a hollow. It is equal to negative 2, so I have a point, another point. The graph of this line is not continuous, but I have a limit here. Guided practice of example number 3. What is the limit of f of x when x approaches to 1 from the left? What is the limit of f of x when x approaches to 1 from the right? And what is the limit of f of x when x approaches to 1? Here, the definition of the function of f of x given by x cubed plus 2 if x less than 1, and it is equal to 2x plus 1 if x greater than or equal to 1. Look at x less than 1, it means this is the definition of the function when x approaches to 1 from the left. So we can replace x by 1 here. So 1 cubed equal 1 plus 2 equal to 3. So the limit of f of x when x approaches to 1 from the left is equal to 3. Now what is the value of f of x when x approaches to 1 from the right? From the right, it means I will use the second definition of this function. When x is greater than or equal to 1. Replace 2 times 1, 2 plus 1 equal 3. So the limit of f of x when x approaches to 1 from the right equal to 3. Since we have now the limit of f of x from the left is equivalent to the limit of f of x when x approaches to 1 from the right, they are equivalent. So I have here the limit which is equal to 3. By the same way, we can solve the second question. Try it by yourself.